Hello everyone, I'm Alexander. I've been a student here at Storing Robots for many years now, and today I want to just present a personal project I've been working on for a couple years. I find it interesting. I think it may be interesting to some of you, and also maybe inspire some to work on their own projects and learn about the processes of doing a project like this. So, the idea started out a couple years ago. I'm members of the swim club, and it's a couple miles away from where we live, so it takes a bit to drive there, and especially during the start and end of the season, the temperature of the water can be very changing. Some days it'll be like frigid when there's a rainstorm. It's like not very nice to swim in, and then other days it's like 80 degrees. It's like, oh yeah, you just get to the pool immediately and start swimming. So normally, like, you'd have to go and just have one of the old thermometers floating in the water to check, oh, is the temperature nice or not? And so I had the idea. I was doing some experiments trying out with Wi-Fi controllers, and a project idea came to mind. What if I had a way of seeing what the temperature of the pool was at home? That way you would know, oh, is it a good day to go or not? So I first did some small experiments with just a little floaty for the pool, meant to put your drinks in so you can have them in the water. And I dropped a Wi-Fi controller here with a waterproof temperature sensor, and that seemed to work. You could get the temperature of the water, and I could access it on my computer, and that was neat. So the next step was, how do I make this a more permanent installation so I can leave it there for weeks on end? I don't have to monitor it, because one thing with projects is, where is the location? What is the surroundings, the environment, so that it can handle staying there for a long time? At the pool, there's crazy kids and stuff, so you have to be careful where you put it. Just having it float in the water, it's going to get thrown around. You have to be careful. So the idea was, put it down by the slides. It's a more hidden area. It kept safe. And so I mounted it there. The next thing was, how do I power it? Being under the slide, it was far away from any outlets. It was right next to the water, so you couldn't just run an extension cord somewhere. That was out of the question. So batteries were the only option. So I turned to using lithium-ion batteries. That's the type of battery that's in your phones or computers. They have high capacity, and they're perfect for this type of application. So I got one such battery, and I used a certain trick with the controller so that I could have it run for a long time. Because if you have the controller just running continuously, the battery would drain quite quickly. So you'd have to plug in almost each day or something, which is not sustainable at all. So I used what is called deep sleep. So the controller basically goes into a low power state where only the bare necessities are running, basically the real-time clock. So it keeps track of time, and so you can say, okay, every 30 minutes, wake back up, and so it can connect to Wi-Fi, send the data, and then go back to sleep. So that prolonged the battery life quite a while. Around 5 days it could work according to the calculations. The thing is, I did not know all the nuances of lithium-ion batteries, and so I plugged it in, ran it for the 5 days, and then when I go to charge it, I ran into over discharge. The problem is, if you discharge the battery too much, then it loses capacity and basically becomes unusable. So I found this out, and that sort of put an issue. How do I make sure that the battery doesn't over discharge? So there's protection circuits, so I added one of those. But the fact that it only lasted around 5 days wasn't ideal, because that'd mean I'd have to each week go and plug it in, and if I want to really have it as a setup, what happens if I go on vacation? Then it's going to be left not working. So the sun came to the rescue. You can use solar panels. And so solar panels, with that, it could run practically indefinitely. The thing is, there's only sun during the day, so you have to combine batteries plus solar panels, and then you charge the battery during the day and run the system off of that. And then in the nighttime, the battery discharges and the probe can run all the time. So I did some experiments in the off season at my house. I built this weather station setup, and I tried out some new solar chargers. This is what it was like inside. This blue board did the trick, and so I could have it where it would be self-sustaining, and you could see it would charge up and then discharge throughout the day. And so then with the temperature set up, I mounted the panel up on the top of the slide, right where there would be sun, and that worked out quite well. So I combined the solar, the battery, the new setup to this revision 2, I like to call it. So the container, the way I had it mounted, it worked, but putting it inside a salmon cream cheese container, there was room for improvement. So also the wiring was a bit finicky. Like if I were to unplug something, I need to update the code. All of a sudden, oh no, I broke a couple wires because it was a total nest inside. And so while this did work for a couple months for the rest of the year 2020, and then I ran it in 2022 as well, I started to see some flaws. Also, this solar panel let me down because it's made out of resin. It fogged up. It just got pretty much unusable because of the way the plastics degraded on the surface. And so I tried sanding it and stuff, but that didn't work out in the end. So this year really was, I took all these things I learned and made some significant improvements. So starting off with the case, I went to a fancier 3D printed case with waterproof seal there, so it clamps down nicely and so water didn't get in. I soldered all the connections. I made a green board back there that has all the connections soldered together so you can't mess them up if you're trying to connect something or disconnect something. I have the proven solar charging and battery set up, and I got a new solar panel that has a glass surface on top, so that doesn't fog up like plastic does permanently. You can just wipe it down and it's good to go. And I have it mounted up there so it gets plenty of sunlight. So this setup works quite well. I set it up at the beginning of the summer here, and I didn't even touch it until 2 days ago when I finally unscrewed the lid and no water inside. So it's been working quite well. So that was sort of the hardware journey. In terms of software, there's one service that really made the whole project quite easy in terms of software. It's called Adafruit IO, and so it's a service where it's free, which is very nice, and it's basically a server in the cloud where you can have the controller send the data there, and it'll store it and then host a website for you to see. So the way it works, like when the controller wakes up from deep sleep, it connects to the Wi-Fi network at the pool, and it uploads the data to the server, and then you can go on your phone, your computer, at home, wherever you want, and then view the data on a dashboard. And so here it is. I have the link here, and here's the live data. So you can see right now it's 76 degrees at the pool, and we have the history of it. You can see how during the night it cools down, during the day it heats up. This was a couple days ago when there was a rainstorm, and so the temperature plummeted. So that wasn't the most fun to be inside. And also have just more for diagnostics. There's the battery, and so it really doesn't discharge that much. The solar panel does the trick of charging it up during the day in the peak, and then it discharges in the night a bit, and so that's exactly as expected. And so it's just been running without fail for several weeks now. So that's pretty much the project here. If you have any questions, please ask me. It's definitely a fun project because it it's not just a project that works at home where I benefit from it, it's everyone at the pool also benefits. Like when I had it, I need to do some work on it. Some people were like, oh, the temperature sensor is not working. I always check it because I want to know if I'm going to the pool. And so it's nice because everyone gets to use it, and it's been working quite well.
How about the winter time?
The winter time?
Is the pool even open?
No, so
It's not
I decommission it during the winter, basically just take it all down, and that's usually where I do improvements. So winter time I made the new case and everything, and so this
The pool is heated in winter. So.
So this is what you were doing with the week that I was here?
Yeah, I was doing that, and also some other projects similar to this with uploading data wirelessly.
So that's why your balloon popping right now, because you took more time.
Yeah, I was busy on other projects.
So what did you do differently for the solar panel? Because you said the first one fogged up. What about the new one?
It's made out of glass. The top panel is glass, so it's a bit more pricey, but it works a lot better because with the resin, like even like the cheap solar lights and whatever, they all seem to fog up. I haven't had much success with those.
Okay, interesting.
Yeah.
Did you create a like a public application for people to be able to monitor the?
Yeah. The Adafruit IO service, they have this they allow you to create dashboards, and so I made it public. And so if you just go to the link, then anyone at the pool, like I have QR codes set up, and so then they can see the data and make decisions
Right.
based on that. So that's how everyone can see it. Because normally hosting websites, creating it securely is not the easiest thing to do. So it's nice this service allowed it to set up quickly and easily. Yeah.
So since you're using the Adafruit IO, this will integrate with IFTTT, right?
Yeah. You could set up automations with if this then that.
Yeah.
There's also some built-in stuff. I have it where if there hasn't been an update within an hour, because it goes every 15 minutes uploading, it wakes back up from deep sleep and sends the data. So if it hasn't done it in an hour, it'll send me an email. And so the worst is when I'm on vacation, I get the email and it's like, no, it's not working. I can't actually go fix it. Yeah, so I haven't done too much other automations with that, but it is possible. Okay.
Can you show the code?
The code, there's not a ton going on per se. It's a lot of it is just taken care of through libraries and stuff. But basically, it just connects to the Wi-Fi and then uploads the data. I guess I can pull it
What
up.
did you program it in?
It's programmed in the Arduino IDE, like the Arduino language.
Yeah.
It's nice because I'm familiar with that from other controllers, and so working with the Wi-Fi controller, the ESP8266, it was not too much of a learning curve to then get it working with Wi-Fi. So, yeah, it's just about like you have to have the Wi-Fi password and username and password set up in there, and then the feed names. Because the way the Adafruit IO works, you have what are called feeds, and so I have the temperature feed and the battery feed, and so then you can plot those in the dashboard there, and then everyone can see it.
And for the whole thing, how much percentage do you think you spend your time on the hardware part versus the software and coding?
Yeah. For this project, it was a lot more hardware based in a sense of setting up all the probes and getting the case designed right and all that journey. The software worked almost right away in a sense because it's like they had examples and stuff, and so it wasn't too difficult of a coding project per se. I've had other projects where it's a bit more complicated. 2021 code. It's the latest. So it's really just about the so it's basically just setting up the sensor. So you have the feed set up here in the code, and then setting up the sensor. The sensor is neat. It uses what's called the one-wire interface. So it just uses a single data wire to communicate. That's actually used also in laptop chargers, like the barrel jack ones where there's like a center pin in the center. That one actually is a one-wire communication to a little memory chip so that the laptop knows how much power the charger can deliver. So in this case, it's a temperature sensor that's using that connection. So it's just a single wire for the data down.
If it's one wire, is it like the Dallas protocol?
Yeah, Dallas
Oh,
one wire.
God. Oh, no, good.
Well,
Sorry.
it's it's been working so it's been working fine. So I'm sticking with that. And so it's basically just you request the temperature, and then it connects. And there's connecting to Wi-Fi basically. I have it where if it tries a bunch of times to connect and it doesn't work, it goes back to sleep so that it doesn't drain the battery. Keep trying to connect. And that saved me because sometimes the Wi-Fi network has been down, and so then it won't drain it completely, and it can recover from that. And then just request the temperature, publish it out here, you save it, and then deep sleep. So basically, once it goes into deep sleep, when it wakes back up, it goes all the way back up to the setup at the top. It's as if you restarted it, except that it woke itself up. Yeah.
A lot of microcontrollers don't support that protocol out of the box, the Dallas protocol, right?
Yeah.
So Are you using like a bitbang library?
Yeah, the library, it's not like the ESP8266 has a peripheral for that, but
Oh, so it does?
it doesn't,
Oh,
so,
it doesn't.
so yeah, it is.
So it is bitbang.
Yeah.
Okay.
Yeah. But it's not like I'm trying to probe it a lot of times where the overhead of bit banging it would come into an issue. So.
How's your 8266 doing like when it goes into deep sleep? How many milliamps is it pulling?
I don't have the graphs on me. It's around 15. I did 15 milliamps. I did some power profiling. But I'm running a 2000 milliamp hour battery cell, and it charges up to full capacity with 1 day of sun, basically. So I could work to get the power draw even lower, but given the size of the panel and the size of the battery, for this case, it's working, so I don't see a need to drop it anymore.
Okay. You don't have any issues with the 8266 waking up, do you?
No, it's been.
Well, when they first came out, I bought one. The thing wouldn't wake up half the time, right? You would get errors, and then they tell you, well, just run a capacitor over these two pins, and I'm like, what? It's like, okay, that's a weird thing I have to do. But
Yeah, it seems like this board it's not like the ESP01 boards where it was just like those little four connections or whatever for communicating, because actually originally they were just using it as an add-on controller, but here I'm programming it directly, and so the board seems more built up. It has all the extra circuitry I need. So
let's say I want to replicate the project.
Yeah.
What does it do?
It's basically just having the controller and the temperature sensor, and then in terms of sending the data, it's not too much code. It's pretty.
a lot of sample code from Adafruit.
Yeah, it's a lot of based off of like sample code of uploading the data, but instead of saying just a number, you send it the temperature value. So.
Right, more so like on hardware side. And
Hardware side, well, I'm using some custom things that I put together, but like the green board in the back, I soldered up myself, but it's not strictly necessary. Originally, I was just using jumper wires to make the connection to the temperature sensor, and that works. It just sort of gets pulled apart easily if you're not careful. So it was just like sort of the custom board, but then the controller is off the shelf. It's a couple bucks, and then this solar charger. I did some experiments, and that one proved to be quite effective, because when you're using solar panels, there's actually a peak point where you'd want to draw power from it, because if you look at a graph of the voltage and current you're drawing, there's a point at a certain current draw you'll get the maximum power from the panel. It's called maximum power point tracking. And so the way usual lithium battery chargers work, they'll just set a fixed current draw, so 500 milliamps for example, and say, okay, it draws this from the solar panel, but what will happen is it'll try to draw it, but the panel can't provide that much power. So then the controller will start up, like the charger will start up, try and charge, and then cut off because it can't supply enough, and then go on and then off. And so that's not the best way to do it. There's inefficiencies with that. So this controller, what it does, it starts ramping up how much power it's drawing, until it notices that the solar panel is starting to drop off in power. It can't supply that much, and so then it'll back off a bit. And so it's constantly adjusting. So as there's clouds or people going over it or things, it'll adjust for that, and so you get the maximum power of the panel, and so the battery can charge up properly.
So you're looking to create a bill of material for people to replicate it from?
I don't currently have one, but I could make one up. It's not.
Where's the license?
We're having investors here.
Here's some money for Molly.
Yeah. I actually was interested in possibly making setups and maybe setting it up at other pools as well, because I think it's a pretty neat thing to be able to.
Any questions? Well, I just want to add on is that we didn't teach him any of this. Maybe it's all his fault. So he did this on his own. But then nevertheless, though, if you have seen the other project, that's how it started. So he did some project before with Lego, and then he just made progress since then. And do programming class and all that good stuff. And this is all your fault doing this.
I wouldn't have let him I'm using 8266. You've been using like a Pico or something.
Yeah. Well, now I'm doing experiments with that, so.
Yeah. You can do the PIO with so it doesn't support the Dallas protocol, but a number of people have written a PIO
Yeah.
assembly to do it.
Yeah, actually.
So it
yeah.
basically acts as it supports it.
And with that, you could even have it have the Wi-Fi chip off,
Yeah.
and just get the sample data, and then wake up the Wi-Fi
Yeah.
so that. I
Have
think
you tested that? Like how much? Like when it turns it off, does it really turn it off?
there's actually a digital pin, so you can switch off power to the chip entirely.
That's right. That's right. So it will.
I was gonna ask after if I could try out with the power profiler, seeing how the
Yeah. Do you know where it's at?
yeah, I do.
Okay,
So
good.
test
You
that
know
out
where
and
more
see
of my
how.
stuff is than I do now.
Yeah, so test that out and see how it compares to the other options.
Sure. Get before we leave though, because once we leave, we're on vacation for the next 2 weeks.
So what's the difference?
Alright, so then the next talk is going at 1 o'clock, and